Hey student, welcome back to lecture series on Z transform. For more videos guys, check in my I button over here. Okay, you'll get my complete playlist for Z transform, or as well you can check in my description box. Okay, you will get the complete playlist for a linear differential equation with a constant coefficient. Okay, a differential equation with a constant coefficient, and after that Fourier transform, sine, cosine and their inverse transform plus Z transform, all the complete playlist you will get it into the description box. Okay, in my today's video guys, I'm gonna explain to you all change of scale property. First of all, we understand how the change of scale property it look like, and at the end we go for solving some of the example based on the change of scale property. Okay, so without further ado, let's dive into our today's lecture. We're gonna see first of all change of scale property. Okay, yes, so change of scale property, what the change of scale property, it says that whenever we have Z transform of f of k, it is f of z. Okay, whenever we have Z transform of f of k means it is a sequence over here. Okay, Z transform of f of k is f of z. Okay, but what happen when f of k replaced by some a to the power k into f of k? Okay, so in such a case we replace by f of z by a. Okay, we replace it as the f of z by a. Okay, that means once you get the entire Z transform guys, once you get the entire Z transform, then you have to replace Z by a. Okay, you need to replace Z as a Z by a. Okay, so let me continue some of the example. Okay, maybe it will be helpful. Okay, that will be the very easier to clear the concept. Okay, now see that guys, in mathematics if you want to clear the concept, we have to solve example and plenty of the examples, so you're gonna love it then mathematics. Okay, yes, so let's get to the some example. I'm gonna explain to you all some example here, so it will be crystal clear, everything it is clear for you all for the change of scale property. Okay, let me write one example. So here I have written one example, Z transform of, we want the Z transform of 2 raised to k cos 3k plus 2. Okay, now see that as we can observe here, it seems like that this Z transform it is matches with this one. Okay, a raised to k matches with the 2 raised to k, f of k it is here. Okay, yeah, so we have a which is equal to 2 cos 2k plus a. Now let me tell you one thing to you all. Always remember, whenever you have any constant which is multiplicative over here for cos 2k 3k plus 2. Okay, so in such a case what you have to do, you have to find out the Z transform for cos 3k plus 2. First of all, only find out Z transform for cos 3k plus 2. Okay, now let me write step first. Okay, this one is our step first. Find out Z transform of curly braces cos 3k plus 2. Okay, so I just want the Z transform for cos 3k plus 2. Okay, then later on we are going to apply 2 raised to k over here. Okay, yes, that means later on you have to replace Z by a. Okay, that means Z by 2, a raised to k means 2 raised to k, so Z by a means Z by 2, you have to replace Z as a Z by 2 later on. Okay, yes, that's it only. Let me write this Z transform for this function. Okay, so here we have to apply cos alpha k and sin alpha k as a Z transform, but let me expand this one, cos a plus b. Okay, cos a plus b, what is the expansion for cos a plus b guys? Cos minus sin, cos a cos b minus sin a sin b. Okay, this one is the expansion for cos a plus b. Okay, cos minus sin. Let's apply this one here. Okay, so we write cos 2k plus 3. We write cos 2k plus 3 as, cos 2k cos 3 minus sin 2k sin 3. Okay, yes, this one is the expansion of a cos a plus b here. Guys, replace this cos a plus b in the form of a Z transform. Okay, so we want the Z transform for this function. Okay, yes, so in this case what we do, the constant term which is present here in our Z transform, take it outside, take the Z transform of only sequence where k it is there. Okay, so let's go for finding the Z transform. We write next step. Okay, now see that cos 3 it is constant over here. Cos 3 it is constant over here. We want the z transform of cos 2k minus sin 3 outside here. We want the z transform of sin 2k. Okay, sin 2k. This one is our required expansion for this step here. Okay, I written this step as a this way. Okay, that means this I expanded in the form of a trigonometric function. Then I taken constant outside. By using linearity property, I taken z transform over here. Okay, yes. So it is way easier, guys. Okay, now we have to apply z transform of cos alpha k. So what is the z transform of cos alpha k? Okay, z transform of cos alpha k, we know that z into z minus cos alpha divided by z square minus 2z cos alpha plus 1. Okay, z square minus 2z cos alpha plus 1. And similarly we want the z transform of sin alpha k. Okay, which is can be written as, okay, z transform of sin alpha k, z sin alpha upon denominator z square minus 2z cos alpha plus 1 as it is here. Okay, z square minus 2z cos alpha plus 1. Okay, 2z cos alpha plus 1, that denominator remains same everywhere. Okay, so what we do, in the cos 2k we have 2 as a alpha, and in a sin 2k we have 2 as alpha. So replace alpha as a 2 here, so you will get the required term. Okay, okay, cos 3 keep as it is, cos 3 keep as it is over here, multiplied by z transform of cos 2k. Okay, z into z minus cos 2, z into z minus cos 2, total divided by z square minus 2z cos alpha means cos 2 plus 1. Okay, again this bracket complete. Okay, plus what we have minus between here, so sin 3 over here. Okay, we want the z transform of sin 2k. Okay, sin 2k means z sin 2 upon z sin 2 upon z square minus 2z cos 2 plus 1, z square minus 2z cos 2 plus 1. This one is our required z transform. This one is our required z transform for z cos 3k plus 2. Okay, this one is our required z transform. Now main work it's begin from here. Okay, already we learn how to find z transform like this in my previous lecture, but now we have to apply change scale property, and change scale property it says that when z transform of f of k is a f of z, then we write z transform of a raised to q f of k as a f of z by a. That means z can be replaced as only z by a. Okay, so what we do, by change scale property we apply by applying change scale property. By applying change scale property. Okay, by applying change scale property we replace by z replaced by z by alpha. Okay, z replaced by z by alpha. But in the case of alpha, in this case alpha a raised to k. Okay, now see that z by alpha means z by a. Okay, so we taken z by a, z replaced by z by a. So in our case we have a as a 2. Okay, z by a raised to k. A raised to k means what is the value for a? A is a 2. 2 raised to k it is there now, so we write a raised to k. So this gives a which is equal to 2 over here. Okay, I got the value for a2. So we have to replace z by z as a z by 2. Okay, so wherever you get the z in our entire z transform, replace z by 2. Okay, so let me write the final answer, cos 3 as it is, under bracket z by 2, under bracket z by 2 minus cos 2 bracket completely divided by z by 2 bracket square, z by 2 bracket square minus 2 times z by 2 cos 2 plus 1. Okay, this bracket complete. Okay, yes, so go for the next step here, minus sin 3 under bracket z sine 2. Okay, that means z by 2 sine 2, z by 2 sine 2. So z by 2 bracket square, z by 2 bracket square. Okay, so we are replacing the values here only. Okay, minus, so we have 2 left here value. Okay, 2 minus 2 times z by 2. Okay, minus into cos 2 plus 1, bracket complete. This one is the entire bracket complete. Okay, now see that this one is a required z transform. This one is a required z transform for our given function to transform to raised to k, given sequence to raised to k cos 3k plus 2. Okay, so by using change scale property, first of all we find the z transform for cos 3k plus 2, and at the end we apply to raised to k. That means z, we have to replace z by a. Okay, that means z by z by 2. After this, replace z as a z by 2, you will get the entire answer. Okay, I hope you all have understood, guys, my entire solution. It's not difficult, it's way easier. So I explained here the change scale property. Thereafter we solved one example using trigonometric ratio. Then after applied z transform of these two results, then I expanded this one, and at the end I replaced z as a z by 2. Okay, yes, I hope you all have understood my today's lecture, guys. It's nothing difficult here, everything it is way easier. Okay, just need to remember some specific part here in our z transform. Okay, so that one is here for change scale property. For more example, I'll come with the next next video. Okay, yes, so for next video we stop here for today's lecture. So thank you everyone, thank you for today's lecture.